Assalamualaikum warahmatullahi wabarakatuh, and hi again. In this video, we will explore on the last topic in chapter 5 on specific chi-square tests, which is called homogeneity test. What is a homogeneity test? When will we use this kind of test? Let's proceed to the next slide to look at the topic's learning objectives before learning what this homogeneity test is. This topic's learning objectives are listed as follows. At the end of learning this topic, you should be able to first differentiate between an independence test and a homogeneity test, because you will find out later that both tests have a couple of similarities and differences. Next, you should be able to calculate the expected values denoted by EIJ in a homogeneity test correctly. You should also be able to calculate the chi-squared test statistic value using the correct formula specific for a homogeneity test. And finally, you should also be able to perform the homogeneity test according to the standard statistical testing procedure. As a motivation, let's revisit the simple example on 2x3 contingency table that we had in part 3 video on independence test. In this simple example, we assume that all 20 subjects are selected randomly and can be in any of the 6 cells. That is, in independence test, we do not fix any categorical variable, either the row variable X or the column variable Y, which represent the number of subjects under study. However, in a homogeneity test, we fix one of the two variables and aim to test if the proportions of the other unfixed variable subcategories are the same or homogeneous for the fixed variable subcategories. For example, we can fix a row variable X where we choose 10 subjects from subcategory X1 and another 10 from X2. So the 10 subjects from X1 can only be in any of the 3 cells, either in cell X1Y1 or in cell X1Y2 or in X1Y3. And they cannot be in any of the other 3 cells. We can then ask, are the proportions for Y1, Y2, and Y3 the same or homogeneous for X1 and X2? For this question, the variable X is fixed, whereas the variable Y is not fixed or unfixed. On the other hand, we may want to fix the column variable Y, where we choose 6 from Y1, 5 from Y2, and 9 from Y3. So 6 from Y1 can only be in any of the 2 cells, either in cell X1Y1 or cell X2Y1. The question we can ask then, are the proportions for X1 and X2 the same or homogeneous for Y1, Y2, and Y3? So for this second question, Y is the fixed variable, whereas X is the unfixed variable. Based on these two questions, we can then have an idea how to write down the correct null and alternative hypothesis for a homogeneity test, as shown in the following slide. Please refer to Statistics for Engineers textbook pages 121 and 122, which explains on homogeneity test. The standard or general statistical hypothesis testing procedure is as follows. Under the null hypothesis H0, we are testing if the proportions or distributions for unfixed variable are homogeneous, the same, or similar across another fixed variable. Whereas under H1, the proportions or distributions for unfixed variable are inhomogeneous or dissimilar across another fixed variable. We will use a chi-squared test statistic in this homogeneity test. Therefore, the decision rule is to reject the null hypothesis H0 if the chi-squared test statistic is greater than the right-sided chi-squared critical value at the whole alpha value, where alpha is the level of significance and the degrees of freedom nu. Since we tabulate the data in R by C contingency table, the degrees of freedom nu is R minus 1 times C minus 1, which is the same as the degrees of freedom that we had in the independence test. The chi-squared test statistic is defined as follows. Again, notice that this formula is exactly the same as the chi-squared test statistic formula we used in the independence test. Finally, you should make a correct decision and conclusion regarding the homogeneity of the stated proportions. In summary, a couple of similarities between homogeneity test and independence test are, first, the rejection rule, and second, the choice of test statistic and critical value. In contrast, the differences between the two tests are obviously on how you state the null and alternative hypothesis and on how you write the conclusion. Back to the decision rule and the chi-squared test statistic formula, the definition of all notations such as nu, r, c, oj, and eij are all exactly the same as what we had earlier in an independence test. Similarly, the way we calculate the expected value for the ith row and jth column is also the same as what we did in an independence test, where eij is simply the ith row total multiplied by the jth column total divided by the grand total. For a practical example on homogeneity test, please look at question 10 in exercise 5 from Statistics for Engineers textbook, page 125. The question reads as follows. A quality control inspector took a set of sample data to determine whether the proportions of output components for two shifts produced by machines A, B, and C were the same. The following data were collected. Use a 0.05 level of significance to determine if the proportions of output components for shift 1 are the same for all three machines. In this question, the data are tabulated in a 2x3 contingency table. The data can also be tabulated in 3x2 contingency table like this. Either using the first table or the second table, it does not affect the homogeneity test that we have in this question, where we are to test if the proportions of output components for shift 1 are the same or homogeneous for all three machines. Here, the unfixed variable is the shifts where we want to investigate if the proportions of components produced by shift 1, which implies by shift 2 as well, are the same or homogeneous across the fixed variable, which is the machine types A, B, and C. To answer question 10 in exercise 5, we can begin with calculating the values of eij for all 6 cells. The sample data were given as follows. First, find the marginal totals, which are the row total and the column total as listed below. Next, by using the formula of eij either for all cells or on 2 cells only, and find the rest of eij values by completing the table, you can check that the values of eij are as given in the red brackets as follows. Having all the eij values calculated, you can then calculate the chi-squared test statistics by summing up all squared differences between Oij and Eij divided by Eij for all I from 1 to 2 and j from 1 to 3, and check if you get 36.6753. Based on this test statistic value, you can then make a decision and conclusion on whether the proportions of output components for shift 1 are the same or homogeneous for all three machines, as shown in the subsequent slide. Having calculated the chi-squared test statistic value in the previous slide, let's complete the solution for this question 10 in exercise 5 from the textbook. Please do not forget to write down the null and alternative hypothesis statements, where under the null hypothesis H0, the proportions of output components for shift 1 and hence for shift 2 are the same or homogeneous for all three machines A, B, and C, whereas under the alternative hypothesis H1, the proportions of output components for shift 1 and hence for shift 2 are not the same or inhomogeneous for all three machines. The decision rule is then to reject the null hypothesis H0 if the chi-squared test statistic value is greater than the right-sided critical value, which is chi-squared alpha nu. Since alpha is 0.05 and nu is 2 minus 1 times 3 minus 1, which is 2, then the critical value is chi-squared 0.052 given by 5.9915. Since the chi-squared test statistic value was calculated to be 36.6753, it is obviously far larger than the critical value. Therefore, we should reject the null hypothesis H0 in favor of the alternative hypothesis H1 and conclude that there is a strong evidence from the sample data at the level of significance alpha equal to 0.05 that the proportions of output components for shift 1 and hence for shift 2 are not the same or inhomogeneous for all three machines A, B, and C. Please note that a common mistake students tend to do is that when they write the conclusion, they mention that the shifts and machines are dependent, which is totally wrong because in this question, you are not testing the independence between the two variables, but rather you are testing the homogeneity between the proportions. Another common mistake students tend to do is when they use Chapter 4 approach on testing the difference between two proportions. Again, using the approach on testing a difference between two proportions in Chapter 4 is a wrong testing approach since you have not only two but more than two subcategories for the machines. Furthermore, when you have categorical data tabulated in a contingency table, it should be an important hint or clue that you should perform homogeneity test on testing the proportions when more than two subcategories are involved. Let's look at another example from a past final exam question. Here, when the researcher took two samples each of 250 students from engineering and science faculties, the researcher actually fixed the column variable which represents the number of students from the two faculties, whereas the other variable, which is the row variable representing the game's preferences, is classified as the unfixed variable. In addition, the data are tabulated in a 3 by 2 contingency table. Therefore, to help the researcher on testing the null hypothesis that the proportions of students preferring football, rugby, and table tennis are similar or homogeneous for the two faculties is to perform a homogeneity test, as shown in the subsequent slide. To answer the sample past final exam question on a homogeneity test, as before, we can begin with calculating the values of EIJ for all the 6 cells. The sample data were given as follows. Again, find the marginal totals first, which are the row and the column totals as listed below. Next, by using the formula of EIJ, either for all cells or on the 2 selected cells only and find the rest of EIJ values, by completing the table, you can then check that the expected values EIJ for all cells are as given in the brackets as follows. Having all the EIJ values calculated, you can then calculate the chi-squared test statistic value by using this formula and check if you can get the value around 26.6667, which is correct to 4 decimal places. Based on this test statistic value, you can then help the researcher to complete the investigation on whether the proportions of students preferring football, rugby, and table tennis are similar or homogeneous for the two faculties as shown in the following slide. After calculating the chi-squared test statistic value, again, please do not forget to write down the null and alternative hypothesis statements, where under the null hypothesis H0, the proportions of students preferring football, rugby, and table tennis are the same or homogeneous for the two faculties, whereas under the alternative hypothesis H1, the proportions of students preferring football, rugby, and table tennis are not the same or inhomogeneous for the two faculties. The decision rule is then to reject H0 if the chi-squared test statistic value is greater than the right-sided critical value, which is chi-squared alpha nu. In this question, alpha is 0.025 and nu is 3 minus 1 times 2 minus 1, which is 2. Then the critical value is chi-squared 0.0252 given by 7.3778. Since the chi-squared test statistic value was calculated to be 26.6667, it is clearly larger than the critical value. Therefore, we should reject the null hypothesis H0 in favor of the alternative hypothesis H1 and conclude that there is a strong evidence from the sample data at the level of significance alpha equal to 0.025 that the proportions of students preferring football, rugby, and table tennis are not the same or inhomogeneous for the two faculties. Having done the two working examples on homogeneity test, we are at the end of this topic session. Let's do a checklist on this topic's learning objectives. After learning this topic, are you now able to differentiate between an independence test and a homogeneity test? Remember, the similarities of the two tests include the decision rule, the way you calculate the expected values EIJ, and the formula of chi-squared test statistic value. In these two tests also, the data are summarized in an R by C contingency table. On the contrary, the statements of H0 and H1 as well as the conclusion are surely different for both independence and homogeneity tests. Therefore, you need to be very careful on these matters. Next, are you now able to calculate the expected values denoted by EIJ in a homogeneity test correctly? Are you also now able to calculate the chi-squared test statistic correctly? And finally, are you now able to perform the homogeneity test according to the standard statistical testing procedure? I would summarize that the steps for a homogeneity test are very straightforward and easy to approach. After doing a little bit more exercises on this topic, I certainly believe that you can excellently master this topic easily. Until then, Assalamualaikum warahmatullahi wabarakatuh. See you again in the next video on another chapter. Bye for now and thank you for watching.